Okay. So let's hope the heap works
Yes.
this way. How big you want it to be? Do you think this length is enough?
Yeah, 6, 7.
Okay. Cool. Ah, chill, man. I mean, you get the idea, right? Think of it as a tree. I wish I can draw it and explain it was smoother, but okay, I think it's there. Think of this as an array. Okay. Yeah, start giving me numbers.
Plus 2.
Okay, let's start with 2. Okay, I think I'll have to do so many things here. Oh, it's in there. Okay, and then
2.
హలో ఎట్లా మరి తొందరగా వచ్చేసాయి మరి ఎట్లా ఫోన్ నుంచి పెట్టుకో ఫోన్ నుంచి హాట్స్పాట్ పెట్టు యూట్యూబ్లో లైవ్ చూడలేకపోతే నీకు లైవ్ లింక్ పంపిస్తా కొంచెం డిలే ఉంటుంది అట్లీస్ట్ ఫోన్లో what are we writing? I just used a command. What was that? Reset. Okay. Let's start a new file. This is HeapSort. Even I never did this, I guess. So let's start it with like. I think this came up pretty good. Let's kind of follow the same pattern. Let's hope that's the array we are solving. What's the next step? Is it we need to think of this as an array. Like a tree. How do you think? Any ideas? So if I want, if root is equal to 0 in arrayth position, this being the index, if you think this as root, then what is left of root? So
Plus 1.
let's make this a guy like this, like we all are smart, so let me put it like this so that we can understand that's it, right? Okay, 2 1 probably. Cool. Let's make it 8. Okay, let's remove 1 3. Huh? Remove one more. That line. Okay. Cool. So think that that's the array. Okay. So if I want to, if this is the root, the 0th position, if I want to get this position, what is it that I need to do? I think it is just index 1, right? Plus 1 should do. If it is here, the index of this is 1, but what is the index of this?
It should be 3.
Wait, 2 is in
1, 2,
0
3,
1
4, 4.
0 1 2 3.
I 4 hour.
3 is the index for it, not 4. I mean, it
Uh,
starts with 0. If this is 0,
okay, okay. If it is 0, it is 3.
okay, this is 2,
2,
this is 3.
4, 3.
Okay. Awesome. So now, if it is 1, it is 3 then. What would it be if it is another element here? It would be 7, right?
Mm.
So what's the pattern you're seeing? 0, 1, 7
So previous index
into 2,
into 2 plus 1.
right?
Mm.
So let's also put one more guy here. If it is a 7, it will have
8, 9, 10, 11.
9, 10, 11, 12,
13,
14,
15.
15. This would be 15. So it is right now.
7 into 2
7 into 2
plus
plus
1.
1. So let's start
7 into
with 1. Okay. What is the right one?
plus 2.
2.
Are you sure it is 0 into 2 plus 2, 2 into 2 plus
Mm.
2, 2, 16 to 2, 12 plus 2,
14. 5.
14 into
right?
2 plus
So
1.
without even creating a tree,
30.
we can actually use this to get a right and left of a element.
Mm.
This seems to be interesting. Okay, so if that's the case, okay. And now what we should do is, I don't know either. Let's go check it out. So what this guy says here is, it's just placing everything into an array. Let's wait for it. Actually, right. I mean, when he's placing them, he's kind of changing the location as well. He's checking him with the parent and he's trying to swap them both if they are different. If one is greater, he's trying to swap them both. So he again started placing them into the array. As in, let's hope he's doing something there. So now he interchanged the first element with the last element and he removed the last element, thinking that that's sorted. Again he's checking with the root node. Check 3. Okay. Okay. Mm, so let's play and look at the example here. This is the array he has. That's it. It's just swapping 7 and 4. So let's say it started there. heap sort. Binary heap sort. Let's first define a complete binary tree. So what we just did was a complete binary tree. Let's discuss about this once we start trees. I mean, like the concept of the trees and all. But let's look at the algorithm first. Build the max heap from the input data. At this point, okay, pass the last item of the heap followed by reducing the size of the heap by 1. Finally, heapify the root of the tree. Repeat the method. Finally, heapify the root of tree. So, how does this work? Like whenever he's placing, he's checking that to the parent. So let's see, it is 6. It came to 5. Okay, that's chill. 5 is less than 6. 3 is less than 6. Now he started putting 1 there. Chill again. This is less than 5. Okay. 8, but this is not less than 5. So he's kind of swapping them. Again, he's checking with the parent. He's swapping that. He's satisfied now. He's going on to the next element. Swap it. This is still again 2. This is still again 4. 4 is gonna swap with 1. And that's it. Now I think this is the last element, so it will be the 1. We swap the 8 to 1's place. And then, okay. I mean, you get the basic idea, but I don't think we need to do it that complex. Let's make it easier. So the idea what he's saying is, when you insert a new item into the tree, make sure you fill in the
parent.
parent. So let's start with the sample. I wish I can create trees here. I don't know if Markdown has trees option in it, but yeah, let's go. If this being 9, and also let's create, right, if there is an index left or right, what would be the parent? Can anyone say?
At the moment,
If I give you a item, I want you to know, I want to know what is its parent. If I give index 3, I want to know it's 1. If I give index 4, I want to know it's 1. For 5 it should be 2, for 6 it should be 2, for 7 it should be 3, for 9, for 8 it should be 3, for 9 it should be 4. So can you please anyone tell me? Hmm? So basic math is equal to left unco
by 2.
is equal to left unco. రెండింటిని divide by 2 చేసిన అనుకో,
It will
this will be root index, this will be 1, this will be 0.5 by 2 r by 2, and ఈ రెండిట్లో నల్లిఫై ఏం చేయొచ్చు ఈ రూట్ ఇండెక్స్ కావాలంటే? Yep. How do you make this happen? బై 2 చేస్తే ఒకసారి 1 వస్తుంది, ఒకసారి 0.5 వస్తుంది. సో ఇఫ్ ఐ కెన్
సో అక్కడ రైట్ లెఫ్ట్ ఉంటుంది కదా అన్న, దాన్ని
ప్లస్
బట్టి
0.5 చేసిన అనుకో, ఓకే. ఇప్పుడు ఏమవుతుంది, ఇప్పుడు ఐదర్ ఇట్ విల్ బి 0 ఆర్ రూట్ ఇండెక్స్ డాట్ 5. సో అప్పుడు ఎంట్ తీసేసానంటే నాకు డైరెక్ట్ అది వస్తుంది. బిట్ కాంప్లెక్స్ ఐ విల్ మేక్ ఇట్ షార్టర్ ఫర్ యూ. ఇన్స్టెడ్ ఆఫ్ సపరేటింగ్ -1 దేర్, ఇఫ్ ఐ కెన్
పాయింట్
సపరేట్
వాల్యూ ఎందుకు వస్తుందన్న?
ఇది లెఫ్ట్, ఇది రైట్. సో గివెన్ లెఫ్ట్ ఆర్ రైట్ -1 by 2 int of seal అంటారా, CIL.
సిఐఎల్
సీల్ అంటే టాపా, ఫ్లోర్ అంటే బాటమా? దేర్ ఈస్ సీల్ అండ్ ఫ్లోర్. లైక్ 0.5 ఉందనుకో, యూ సమ్టైమ్స్ యూ కాల్ ఇట్ 1.
ఓకే.
ఫ్లోర్ అంటేనేమో 0, 0 to 1 మధ్యలో ఉంటే ఫ్లోర్ అంటేనేమో పై బాటమ్, సీల్ అంటేనేమో టాప్. ఓకేనా? సో ఐ థింక్ దిస్ ఈస్ ఫ్లోర్ దెన్. Floor of this value would give me the root index. So let's example, if this is taken, -1 would be this, by 2 is root index, right? Nothing to floor there. If I subtract -1 for left L -1, this would be something. Then if I divide it by something, then it would be root index plus 0.5, because I subtracted -1, so by 0.5. If I make a floor of it, then it would also be gone. So to get a root, this would be the formula. Okay, అర్థమైందా? Did you guys get?
Yes, sir.
So child index -1 by 2. Even I never thought about things like this before too. Maybe I don't remember. So well, I need to floor it also, right? So I'll make it integer of. So how do I check? So whenever I'll say I'll divide this into multiple parts. (3.1) How do we insert? So instead of inserting, let's think that we started inserting from index. So let's say you started planting, you say take an index named I. Think I is 0 now, okay? And think if I advances, you placed a new item in tree. Okay, think that. So even here we are thinking tree, right? It's not actually a tree, it's actually in an array, but we are visualizing this as a tree with indexes. Okay, so even here, if I is 0, you think that you inserted I. If I is 1, that means you inserted till 1. That's how you start inserting, right? So take int x is equal to I, and you added a new item now, and I don't think we need this. And 3.2, what you will do is, if a item is inserted, make sure it's less than parent or swap. So when, let's say we started with 9 here, okay, and we inserted 7 next. 7 is less than 9, we are good. And then we inserted 6. Okay, 6 is also good. So I incremented to. Let's also put this thing. We were saying ref, right? Zero, 1, 2, 3, 4, 5, 6, right? So that's being the reference. We started at 0, 1, 2, and 3 being 2, 4, 3 is, oh no, but when we started inserting 3, oh yeah, it's 7, 2 is less than 7. When 7, 2 is less than 7, and 1 is less than 7, 3 is less than 6, but 8 is not less than 6. So we got a issue now. So what we need to do is check this with the parent. If it is less, we are good, or else we swap it. And again we need to check it with its parent till we reach the index equal to 0. Okay, or swap parent till root. So how do we make sure? Like, let's write a let's make a function for this guy. Okay, and then after that max heap is constructed, uh, sorry. Eh, okay, after heap sort is constructed, we need to swap the root with the last item. Continue. Okay, I think this is enough understanding. I think most of you understood, right? So let's start writing the code and see it, visualize it, so that we can understand it better. Writing all this is so bad. So let's create a new file. Ramesh, are you there?
Yes, sir.
సార్ ఏంటి సార్ అదే అంత సీరియస్గా చెప్తున్నాను నేను క్లాసు
Yes, sir.
ఏ అన్న లైక్ యూ కాల్ మీ శిరీష్ ఎస్ నో ఏజ్ గ్యాప్ ఓకే ఎవ్రీ ప్రోగ్రామర్ ఈస్ న్యూ చిల్ ఓకే మనం ఇప్పటి వరకు లైక్ అది చేసినాం లెట్స్ మేక్ ఏ కోడ్ ఫర్ ఇట్ ఓకే మేక్ సమ్ రైట్ సమ్ కోడ్ బ్రేక్ సమ్ కోడ్ so let me start with definition. The name would be HeapSort. I think I'll name the sample. So that being the array, let me put this side by side. Let me close this guy. Can you see? So think that we have the sample also. We got the sample ready. And just for testing purposes, but once it is done, I'll remove all of these. Okay. So that first step is done. So let's go to the second step. Make it look like a tree. Fine. We have the tree now. We have the indexing things. So let's start inserting. Let's call inserting into tree virtually. So if I call index is equal to 0, this is how I index in range of so I guess it starts with 0 till that length, right? So think I as the index. So
left and right.
so think it started with 9 I. So what we need to check? We need to check it with the parent. If I okay, let's go on to the second element. So let's think it went on to the second element. What we need to do? If it is at 7, I need to check if check if the parent is greater than or less than or equal to 0. So let me do one thing. Parent now I'll introduce you to a new concept called type. Yeah, ignore. I don't think we need too much of things in the scope right now. I wrote a parent function. If I give index, it gives me. Do anyone know lambda functions in Python? So lambda functions are one-liners. You can have very good pretty lambda functions, okay? So this is a lambda function. Parent node. Let's call it parent node. Parent node is what? Integer of. Okay. Wait. Okay. Does it have const? No. So let me define few functions here. So to get parent node, this is the lambda. So lambda is a short function. Let me explain you. So before I was writing this, right? So this is what I wanted to do before. I'm gonna give index. It's gonna return me. The index of. And if I give sample as well, I think that I can get. Index minus 1 divided by 2. I think this was the parent node, right? So I wanted to write this, and so let's write it all of it. Left node. So what is the left node? Index into 2 plus 1. And let's remove the sample, we are not using it anyways. This is right, but what I'm doing is I'm converting that into a small lambda. If given an index for parent node, then it would be int of I. I don't even need index. So I should do int of I minus 1 by 2, right? So that's a small lambda function for parent node. Both of them do the same job here. Like both the same. This I want it to be I into 2 plus 1. This is plus 2. Also this is right node. So you have all the functions. I don't think we'll need these anymore. So given an index I, if I double is equal to 0, now just continue. If I don't think we need brackets here, right? So plain as well. Phi, if sample of I greater than, I mean the child is greater than the parent, sample of, we want parent, right? Parent node of I. Got it?
Swap.
Means swap. So how do we swap? Sample and let's write a function for this actually. Now let's write, I don't know if it can come inside. Okay, this step will swap them, you know, and for your safety is equal to b comma a. And then if not, even that case didn't work out, so they're good, then we, so even this case won't stop, right? We need to do it till it reaches the root. We just stopped it at one level, so think that it is now here, right? So we need to make sure that it goes on till the thing is there. So let's put some value, some j is equal to I. So I mean I just copied the I value so that the still this range is going on good. So I made a new copy, and so I being the current value and j being its parent. Yeah, that should be cool. So sample of j greater than, is there something like do while in this in Python? Okay, looks good. And I need to increment, well, a sample of j greater than 3ai or j double equal to 0. So it's not equal, well, j not equal to 0 and the parent is smaller than the current thing. then we keep on swapping it. Okay. mm, J is equal to parent node of J. Cool. I mean, if this is I think this shouldn't confuse you guys. Do anyone have any doubt? I want to know first. Did you understand this statement, like what I did here in these two lines?
Mm.
So what I did was, like, we came to a point where the node can be anywhere. Like, it can be a very big tree. For example, take this heap. It can be 1. It can be at very bottom. So we started inserting. Think we are inserting 10 here. And I wish I can pause this. Let's start. Okay. Let's have a fixed image so that it doesn't go. So yeah, think instead of 6 here, we are inserting 66. Okay. So 66 is bigger than 9. So what we need to do, we need to swap these both. Then 9 would come here and 66 is here now.
Mm.
So 166 is here, we need to swap it to 2 because 2 is smaller than 66. So we need to do it till it reaches either a 0, either it is the maximum number and reaches the top, or else it stops at some point where its parent is already bigger than itself.
Mm.
So I need to make, I don't know how long the parent is going to be, so I'm making it such that either j equal to, this while loop will stop if j is equal to 0, or sample of parent node is greater than the sample of I. Like, this is an opposite statement, right? If while j not equal to 0 and the child is bigger than the parent, then swap it and put the index to the parent and continue. It continues, and it kind of swaps all of it. And another case where everything is fine, I don't think we need to do anything. So by this point we might have had a max heap, right? For first position we are not doing anything, and by this point we have a max heap. And let's try to print it out for our debugging statements. Print max heap. We are doing everything in place, so I think sample will contain the latest exact values. You know what in place is, right? Saif and Ramesh. Do you
Sir,
know
repeat
what
here.
in place is?
In place. No.
So when there is an array and you're swapping the values inside the array without making a copy of an array, then it is in place. For example, I'm just swapping the values of 8 and 9 and only in this array. I could do one more thing where I just can create this as 1 and this as 9. I swap the values here. I can say it is a sample 2 and sample is equal to
Babu.
sample. So if I did something like this, like when if I make a copy and then if I'm assigning it, then it is not in place. Then it is not
But
in place.
Anna, but sometimes it shows when I do it this like it will show concurrent modification exceptions.
Yeah, if you do this, you are not doing it in place. If you are doing this, if you are trying to change values of like sample, if it means s of I comma s of j, I index exactly, like in C, if you take, then temp is equal to, you will take this swapping, right?
Yeah.
And you say s of j is equal to s of I is equal to temp. This is what you do, right? To swap.
Yeah.
So if you are doing this, that means you are doing it in place. The same address, the array space is same. You're just trying to swap the values inside. But this way, what you are doing is you are making a copy mean, you're just creating a new random copy, and you're trying to push it here. You're kind of trying to update the change the address. Initially, this can have an address space of ampersand 001. Okay, and it would have been somewhere between 00 some 30 or somewhere 31. And when you're trying to do this, you're actually setting this value to 31 in the address space. Think hard disk has a zeros and ones, right? If you think the address like 1 being the first address point of a disk, this would have been stored in 001. The sample, if when you say sample, you are referring a 001, and when you're saying sample to your, since you created a new clone, it would have a different address. And when you're swapping this, when you're assigning this, we're updating the sample's address to this address. You getting me?
Yeah.
The sample is not actually the same, but if you do it this way, swapping, then the same space, the same things would get swapped. I mean, the disk is the same. You're not creating a copy and you're not pointing it separately. So this is called in place, the top one, and the bottom one is called, I don't know. I don't know what to call it. Something which is not in place.
Okay, fine.
Okay.
Okay.
And okay, so I think you guys got better understanding on that, and let's continue. So think that we displayed a heap here. So now that the heap is done, what's the next step? We need to construct it. We need to swap the roots with the last item and repeat. Okay. So I'm swapping sample of 0 comma sample of -1. Okay, I did this, I changed the swap, I changed this, and sample length, let's change the value later. Okay, once I changed it, I need to do what again? I need to start checking the heap for the bottom thing. Like now that for this array, see, he swapped 7 and he removed the 7. Then he started checking with the child from the on the left child. If the left is good, he is checking the right, and is continuing the process, right? To make sure the heap is good again. So let's, once we are swapped, let's decrease the scope. Decrease the scope of by 1. Okay, so minus is equal to 1, so I decreased it by 1. Now that means now the array length is actually not 6, it's 5 now, because now that we swap, we think that the last one is sorted. I mean, I'm just reusing the same variable here, array length. Let me see if we can make a recursion on this and try to get it. So now that we changed it, do you think this logic would work to create a heap again? You started with 1 and you check with the second element. It will change it because it is it's different. It will swap. Will continue till this is done, and you kind of iterating the same thing again and again till the sample length is 0, right? I think this is the part you need to repeat until the sample length is 1. So what I'll do is I'll just break this part. Sample length is equal to 1. I think it's while, not while it's greater than 1. You do this, repeat this body. Once this is done, I hope I might have had a max heap. Let's okay, let's see how it is doing. So let me copy all of these, and we haven't used right and left anywhere. There's no point in writing them. We're just using root, parent, parent, parent. But yeah, good to discuss though. So I'm missing Linsify in class. She used to talk something or the other. You guys are so silent. Yeah. Okay, so let me close this document and let's test it against our infamous. So let's say I don't know what this guy does. So since counting sort is in place, we need not make a result because it is in place. We are not creating a clone, so we need not return anything. Whatever we send the array, right? The array will get in place sorted in the end. So even this array, right? It need not return anything. It can be just a function which returns nothing. You send an array to it, it will sort it and send it back. Let's hope it works without breaking anything. I don't think we'll need a maximum value here anyways. So let's have another sample generator. No. Don't debug. How do I duplicate this? Control D doesn't work. Alt J no. Control D. Right. Okay. So sample being random generator 2. I don't think it needs to be random generator 2 anymore. This is something without duplicates, okay? Just need an OS, it doesn't need all of this. What's the maximum value? Okay. Is it sorted? No, right? So let's debug the issue then. Let's take it here. But at least we didn't throw any errors for the first time. Every time we used to do some mistake or the other, so it's an improvement in my opinion. Okay. So this was the initial array it took. So it has quite a bit. Let's try to create a new file and test. So this was the array. So let me make one. 8. This was good. 7, 2, 3, 0, 9, 4, 5, 6, right? Like what if this was the thing when we inserted 1, 8, then we should start swapping from here only. So it would have been here and would have came here, right? Then 7, it's good. 2, and then 2 would have been here, 1 is here. Then 3, and 3 is here, then 2 is here. This is good. This would have been 7, this would have been 8 obviously because it would have been 9. This is 4 and this is 4, so this is 4. Actually putting 4 here, 3 here. I mean I'm just doing it faster, okay? So this would have been 3, this would have been 4, this would have been 5. So 6, this would have been 2. We have it following right? Right, this would have been 2, this would have been 5, this would have been 6. Cool? Now the actual array is 9, 6, 8, 4, 5, 0, 7, 1, 3, 2. Did we get this? No, right? So we took this as an example. Let's kind of instead of this guy giving us example, let's take this as an error. Let's comment this out. Okay. So anytime we run, we get the same thing again because we constructed this. So where do you think we went wrong? Let's also put little more debug statements in between. Okay. Let's say here print child being I, parent being and instead of this being here, let's put it here. So it started, okay, the values, it found that what we did, it found all of them, but let's also put the values of them. Okay, so what did it print? It has space, right? Sample of I, sample I, hopefully it prints the values, and then see, as expected, it swapped 8 and 1. So in our case, okay, this so let's start from the beginning. So this was the array, right? So first what I did was swap 8 and 1. Cool. Then I got a problem with 1 and 2. No, I didn't get. Did I? Okay, 2 and 1. So I swapped 2 and 1, and then 3 and 1, 2 and 3. So why did we get the same number twice? think here we did a mistake. For 3 parent is 1, right? So once this is done, why did it check again? Balu, any idea? And it swapped both 1 and 2 again, right? See, these things are getting repeated. I don't know why. For some reason, we are not doing. Something is wrong. Okay, here we have ice. Okay, this should be J. This should be J. This should be J. And this should be J. So I think it's bit better now. The values. So we start with 8 and 1. Cool, that went good. Then we started 1 and 2 because this is fine. And 1 is good. Why did we start it? Okay, it was like this. So let us do it from hand again. So since 8 is bigger, let's make it 8 and let's make this 1. And then we inserted 7. 7 is good. Then we started with 2. So 2 is bigger than 1. So we made this as 2 and this as 1. Right? So what did we swap? 2 and 1, right? Yeah, the 2 and 1 we swapped here. Okay, then 3 and 2. Then we thought we'll swap both 3 and 2 because 3 is bigger, right? So but here in this index it also swapped 1 and 0, 2 and 8. Means one condition didn't check out. I think this condition here we wrote is wrong. This condition, this one. So let's take a look at it. This means the child is bigger than the parent, or this.
It should be and.
If it is and, sometimes it need not reach the parent, right? J need not reach. So and sometimes if the J is 0, right? Let's imagine J is 0, and if we try to get a 0 minus 1 parent node of 0, it would fail, obviously, because the index of some negative number wouldn't exist, or at least it would have been 0, I guess. It kind of goes into infinite loop too. So what we need to check is, well, J not equal to 0 and that's true, and sample is correct, remove it. That's it. I think this is the fix. Sorted. We have a sorted sample. And 9, 6. Was this the thing we got before when we solved? That's long gone, I guess. Yes, so this obviously that would be the thing because we did it. We got the answer. Don't save. And we close, buddy. Let me remove the comment so that we can look at the values good. Sorted sample, all the things. So it's sorted for those samples, and now let's again run the actual sample algorithm than we providing one. So let's say 100 values. Are they sorted? Let's try 10,000. We got the sample. It's taking a lot of time to solve it. So let's see the heap sort complexity. The worst case is n log n, then it should be faster. Why is it slow? Let's decrease the number to 1000. 1000 got sorted better. Let's take 4000, which was the cap for the quick sort also. So let's take 2000 then. So 2000 took quite some time. 3000. This happened. Okay, let's make 5000. These things, I think they should be fast. Okay, this guy got HeapSort Python. Let's see if some guy wrote a program which is much faster than us. Usually these guys are fast, so I wrote it two functions, heapify this and that, and that being the array heapsort. Okay, right. Shit, it's fast. Then I think we did something wrong and we messed up somewhere. This is faster.
What changes did you make?
I didn't do anything, I just copied someone else's code and it was faster. Some reason not ours. That means we did some mistake somewhere. Maybe we actually did follow the algo. So let's see what this guy said. So there's a heapsort n being the array. So he started reducing one number at a time and he's doing heapify. Function in the top. So largest is the element as the root. So left, right, see if the left child exists and is greater than root. So if I say is greater than root, change root if needed, heapify the root. But this is a recursion. We are doing it into this, but yep. Faster than us. 1 lakh, you know.
Do for 1 lakh now. Try for 1 lakh. Sampler is not generated yet.
No, waiting for this sample is way bad, so let's write some small thing in here till then. Some kind of notion saying, yeah, this is there. sleep.
Second turn.
So if I want to see seconds, this is it. To see minutes, this is it. If I want to see 5 minutes at a time, okay. This is common for every 4 seconds. Okay. So
Both.
time gargani some x time may not put time. Interval is also not necessary. Time value probably if is equal to this, displaying the time, right? నేను దీనికి ఇక్కడ బ్రాకెట్ మిస్ అయ్యి బాగానే వచ్చినాయి బ్రాకెట్లు ఇక్కడే ఎక్కడెక్కడినాయి. ఓకే, ఆల్ దిస్ ఈస్ గుడ్. We can put this as an interval. ఇక్కడ ఇంటర్వల్ పెట్టేస్తాం, ఇక్కడ ఇంటర్వల్ పెట్టేసినాం అంటే
Eight time.
ప్రింట్ చేసినప్పుడు ఈజ్ ఈక్వల్ టు ఓకే. అది పాతది, ఇది నాట్ ఈక్వల్ టు అయితే ప్రింట్ చేస్తాం. ఓకే. So if I get the test here, what should I know? If I can print every 4 seconds కి ఏం ప్రింట్ చేయొచ్చు నేను? x వాల్యూ ప్రింట్ చేయొచ్చు. x maximum is NOS, current value is greater than 0 and we are decrementing it, right? So NOS minus x, this is the percentage 100 into let's see if this works as expected. So what is it? Too many potential arguments for the function. Okay, so let's say we are accepting more than one item here, so I think we need to put star. We can also print I'll tell you what that is later.
Check for small numbers.
So we kept this in duplicates. It is different. We have x starts from 0, so I don't think we all need this. Then a percentage ante x by n is 200 na. Last print state reference before assignment. Before assignment. What? How do we do this? Is there anything like static in Python? Did you anyone see? It's something like static or so. What are we missing? Doesn't have anything, right? I guess. స్పెల్లింగ్ అని తప్పుందా? సేమ్ అదా లేదా?
లాస్ట్ ప్రింట్ ఎట్
ఇక్కడ ఉన్నందుకు ఫీల్ అవుతుందంట ఇది. ఇక్కడ ఉంటే అక్కడ ఉంటే నాకు ఫీలింగ్ ఏంటి అసలు. సో లెట్స్ kind of exit and let's say we started, so let's say we exited, imported time, we did this. So now we'll print at interval yo. బాగా సతాయిస్తుంది రాని. ఎవరైనా పట్టుకుంటారా ఇష్యూ ఏంటని? పర్సంటేజ్ 36 అనేది. Let's make it smaller and smaller. Yeah, but this is the sort. I think we are wasting too much time on this. Why don't you guys look it up? I think where we went wrong could have been reusing the same function again and again. Look at this code as well, what we copied from Geeks for Greeks. And you know, like, I want someone to come up with this thing, like this is the reason why we weren't able to make 6000 mark, because with this guy's code 6000 was a breeze. Let's for now remove this code. Now what I tried to do here was try to print at a regular intervals, not often. There is something like that, but it didn't work out. So 1000 vendors went good. So let me make 10,000. See, when 10,000 numbers got sorted quick. But our code didn't. Can anyone tell me why? Can we debug now? What do you think is going wrong? What do you think we're doing wrong? So after I'm not going to print anything. Yeah, it's printing all of the numbers, and where last numbers it's getting sorted. That's very slow. I mean, this iteration is taking a lot of iterations. I mean, the first sort. Okay, I want you guys to figure that out and let me know tomorrow. We spent enough time already. 12:20 is time. Closing the class here. I think I need to check too why it is making too many iterations. I don't think I can sleep with this. But yep, that is it for today. We kind of implemented HeapSort. I think we kind of face a similar issue in QuickSort as well. Please do check the code of QuickSort too. You know, if you can find the solution here, I want you to find solution for QuickSort as well. Even the QuickSort, right, it is taking like huge amounts of time for 6000 numbers. But what we thought was it is slower for bigger numbers, and it is slower if the thing is in ascending order or descending order. It is n square. It has a worst case complexity of n square, whereas the HeapSort doesn't have any such. But I don't know why this guy is taking like hell lot of time. Okay, I think I know the issue. Cool. So what we are doing is post the swapping, right? We need not iterate over every item again, so which we are doing it here. So what we are doing is, this is a insertion step, right? This was actually what we thought was, as was an insertion step. By this repetition, this shouldn't be insertion. Like it's just you start with head and you just try to make the heap. But in this case, we are kind of iterating over all the sample again. Like we are creating an n square complexity here by iterating over every item again, like n into, we are decreasing one element at a time, but we are creating n of n plus 1 by 2 iterations. So I think this is n square here. Oh, then what we should do is, once the sort is done, right? Once the swap is done, we need to do heapify. Phi from root. How can we achieve that here? We start with 0, and I think this is the code from child to parent, but we want something from parent to child as well. So I think this could be something like this. I think this would be in the while loop, right? So what we did is, while finally sample length, I think this is the while loop we need to put. This is just insertion, just ignore this part, forgive me. I think so. While sample length is greater than 1, we are just kind of swapping it. So we swap the first element with the last element, and we decrease the scope by 1, and from here we need to make sure swap from root to make it perfect heap. So I think I started with the root now. So while probably let's make use of the same thing here. So I think the j is 0 now. J so now the condition, what it won't be 0, but sample dot get j comma none. There should be a sample j, and there should be a sample parent node of j, and then I will check, I mean not the parent, I need left child, I guess, right? So here I think we need to write that logic. Let me write. So I started with parent now. If sample of j greater than sample of left node. So there is left node and it's the parent node. So parent node will obviously be there. That's the reason why we are here. If there is left node, let it be if and left node. So if the left node is, the parent is greater than, it's fine, but if it is less than, then we need to swap. This would be the left node, and this would be the left node. Okay, now J would be the left node. Okay, then we also need to check else elif for the same thing, but for a right node. So we jumped. Okay, we'll do the same.
Right node.
We're removing.
Right.
Okay, and what we need to continue again. If this both did happen, I think we are good, right? I mean the tree is done. If this happens, we need to continue again. So how do I say, while sounds good. I mean this is a infinite loop. I start with J and I replace it with J all the time, which I don't want to. So J would be before that. So once I go inside, I'll check if there is a left node. If there is left node, it's good. Then I'll check if the left node is bigger than the parent. If the left node is bigger, then obviously we need to swap them. So we swap them. Then if there is no left node, then we check for the right node. I don't think, if there is a no left node, do you think we'll have a right node? Because tree starts from left to right, right? If there is no left, we will not have a right.
Left is compulsory, right is not.
Yeah, but if there is, okay, so we start with left. If there is no left, I don't think this would even come. There wouldn't be a right. But yeah, but if this condition fails, left exists and this condition fails, then it would come onto here. It will check if there is a right node, and if the right node is bigger than the parent, then we swap the right node and parent, and we'll just pass the J as next node and we'll continue the loop. But if this is good and this is good, then that means that the heap is sorted. Then we can say break. If I say break, then it will exit out of this loop, while loop. There are two statements, break and continue. I want you guys to read about them. Hopefully then by this time, I think it should have been a sorted thing. I'll come here back here again. I'll see the length. Okay, issue none. Let's hope, fingers crossed. Let's remove the proof statements. I think we have it from the bottom. So get doesn't exist on list. So what exists in the list then? Here we go to, this is the list. Array of 10, obviously out of range. How do I get then? Index 10 is not in the list. So I don't know it. I think then, since I know the length, right? What are the how to check if the index is available in the list? I think only by length. Index, sort, count, clear, copy, set it, tr, get item. so even that won't work. I don't think we can do this part here then, so we can do one more thing. Since we know sample length is greater than, so if the sample length is for this array is 0 1 2 3 4 5 6 6 stays, okay, then it shouldn't be 6. Yeah, it should be less than. Cool. Then what's the problem now? Says list is out of range. Should we put -1 there? Let's work here. They shouldn't copy paste something randomly like that. So let me print sample so I'm printing sample left node j, and I don't think I need any of the other things, so sample length is 1 and 0, so 1 being the left node, 0 is the parent node, and it is iterating, infinite loop, I guess. 1 0 1 0 1 0 1 0 1 0, then 11 and 15. Sample length became 11 here, I don't know why. So we start with sample length 9 8 7 6 5 4 3 2 1 1 1. Don't know why these many ones. So this was the array. Sample length is 9 now. So 1 was the left, and it broke when, I don't know why did this 11 come. The sample length is 1. We got 11. 11 is the value of j. Why did we get it as 11? Who set 11 here? Either left node or right node. Setting left 5 ఉందంట. What was 5? J value 5 వచ్చింది. వన్ ఉన్నప్పుడు 1. This is good. శాంపుల్ లెంత్ 1కి వచ్చిన తర్వాత బేసికలీ ఇక్కడ నుంచి సార్ట్ అవుతూ వచ్చింది అసలు. Take a value. So this was the thing, and this became 4, so because we swapped with 8, and then we installed 0, 0 is good, 3 is good, 2 is good, 1 is good, 6 no, so this became 6, this is good now. So 7, so let's make this 3, this as 7, and then this as 4, this as 7, sounds good. 5, this will become 4, this will become 5, 9, this will become 2, this will become 9, and this will become 7, this will become 9, this will become 8, this will become 9. So by the end the array should be 9, 8, 6, 5, 7, 1, 0, 3, 4, 2. This should be the array, right? What did we get? Max heap was wrong. So post this step, we should have got 986, but the max heap came wrong. So I think there is some issue in here as well. We started with 0, I equal to 0, and I think we started with 9, we put 4, and why did the sample change itself to 5 and 9? 9 got swapped here, something went wrong. Okay. Shit. This is happening here. Yeah, I think we got the right max heap now, right? Nine eight six, 570, 342. So till max heap it was right. I'm sorry.
7-1.
710, అది నేను ఇక్కడ తప్పు చేస్తున్నానేమో. Are you sure that is the same? again. 4 8
8,
0 3
3,
2 1 6 7 5 9. So if this is 4, this is 8, then this becomes 4, this becomes 8. 0 is good, 3 is good, 2 is good, 1 is good, 6, this becomes 0, this becomes 6, and 6 and 8 are good, so we stopped. 7, then this becomes 3, this becomes 7, again 7 becomes 4, 7, good. So 5, this becomes 4, becomes 5, becomes 2, becomes 9,
7,
9, this will become 7,
8,
8, 9, 710. ఇక్కడ ఏమొచ్చింది 701 వచ్చింది. సో आई थिंक यहाँ भी कुछ मिस्टेक है क्या हमारा, क्या किया है. So we swapped 8 and 4, that's good. Then we swapped I think we should write this down too. If you're smart enough, we'll find the solution, but 8 comma 4, right? This becomes 4, 3, 1, 6, then 6 and 0 है क्या. Why did
1, 0.
oh 1 and 0, we are missing something, we missed it, not the program didn't miss it. That was the thing. So this is right one. So what we got here is right. Okay, post the swap, post the heap, that was the heap. So let's construct heap based on this. 9 8 6 5 7 0 1 3 4 2 okay. Okay, so if this is the tree, now what we need to do is we need to swap this, and last element would be 9. So I removed 9 and kept 2 here. Okay, so now what I need to do is I need to swap both 8 and 9.
9, and
So this would be 8, this would be 2. Again 2 and 5. So this would be 5, this would be 2. Again 2 and this would be 3, this would be 2. Okay, then we need to place it at the last position 4, and we need to do, but did we get the same? Suppose this should be there, this was good. So sample 9 and I equal to 1. So every time this is the output it is showing. So ij being 1, I don't know why j started with 1. So what we did was we swapped the 0th element, and string length is 9. 0 1 2 3 4 5 6 7 8 9. I think -1 is the mistake we are doing here. 10. Okay, obviously would fail. So -1 is right, even this is right. We swap first and last, and we decrease the length by 1, and then so sample length would be bigger, so obviously it shouldn't touch that index. If there exists a left node and the left node is greater than the parent, then we swap and we say we move on to the left node and we repeat it. While true, since it's repeating. सैम्पल है भाई, इधर एक बार भी ये प्रिंट स्टेटमेंट नहीं हुआ है ना, लाइक प्रिंट सेटिंग लेफ्ट सेटिंग राइट करके एक बार भी नहीं आया. मीन्स थिंग्स आर नॉट गोइंग इनटू दिस लूप. अभी यहीं पे हम we swapped it twice thrice, right? Like when we made it to, so when we changed it to 2, the first element being see we changed, and yeah, the last element was 9. This was the actual array now. 286570134, right?
3, 4.
So post this 8 should have came here. This step 8 should be here, but it, and we didn't swap also. In this, the very first step says swap, but it didn't go through this condition. Somehow it went through the break. So let's check why. Okay, so at this example the sample length was 9 because we already decreased length by 1, so we stopped ignoring this. So this is the last element and this is the first element now. So we started at 0. The sample length, since it was 9, I don't think we need any -1 anymore because we already decreased 1. So initially it used to be 10, so now it is 9. So this is 9 minus, so 2, and left node of 0. Left node of 0 is 0 into 2 is 0 plus 1 is 1. So we should have got left node as 1. Did I get 1? Sample node, left node, okay, and this is the actual node. So 1 and 2 we found, but it didn't swap here. Can you tell me why? It should have entered this relation link, right? Sample of j is, sample of 0 is 2 and sample of left node is 1, so 2 and 8, but sample of j is actually 0. Parent is less than child. Yes, of course. See, it's skipped. So whenever it is skipping, right, let's make sure the values are all good, so that we'll understand what should have been the conditions and what failed. So let's print the sample length and let's print j, and let's print left node of j and print right node of j. And then sample of j, let's continue in the next line. Sample of left node of j sample of right node of j. Okay, let's see. Whenever it is skipping, now we're gonna get skip. So it is the initial value is sample length. I was j was 0, right? 1 second. Yeah, when it skipped, 9 was 0, length j was 0, and the left node was 1, right node was 2, which is right, and the left value, the actual value of parent is 2, the left value is this thing, but it still didn't go through, but I don't know why. So let's kind of print this as well. Print condition 1. So condition 1 was false. What was false?
Sample length.
We'll make it 2 print statements. So always the second condition is true. I mean it says swap, but the first condition is false. First condition in the Monday, sample left less than left node of j. Left node of j వస్తుంది, అది 0 అంటే 1. 1 obviously రివర్స్ పెట్టినాం మనం కండిషన్. Just reverting everything back. పెట్టినాం, బట్ శాంపుల్ లోడ్ పెద్దగా ఉండాలి, చిన్నగా కాదు. నేనైనా ఇంకా ఫస్ట్ అయిపోయిందా మళ్ళీ? వచ్చేసరికి మనం అన్ని కమెంట్లు రాసినవన్నీ సప్మని పీకేసాం. Okay, not a problem. We know where to put the print statement now. Repeat condition 1. Sample length greater than left node. And after every iteration we should have got a proper sample kada. So let's also print sample every iteration tarvata. So post this step, initially the sample was 9. మళ్ళీ 9 ఇక్కడికి ఎందుకు వచ్చింది? Okay, so 9 in 1. So 9 should have been replaced here, right? Why did it get replaced here at 5? Did we replace after the -1 is done? No, right? This was the max heap. Oh, why is the max heap having 9 at the end? So for this sample, was that the result? 480, the max heap is 9 to 2. Why did the max heap get changed again? Okay, I think the tab went back again because when we started. Yep. And yeah, bit going good. So this was the thing. So 8 के बाद 7 आना था. So we put this value and this. Post the swapping, we'll print the values and see what. Let's also, since this is going on to this board too, let's comment these guys out. So initially 9, 8 के बाद, no, this should have been 7 because there is a 7 here. So we failed after this step. So why is this parent? So I'll put value sample j. Hey. What was the problem? Okay. ఆల్రెడీ అయిపోయిన తర్వాత చూస్తున్నాం కాబట్టి స్వాప్ తర్వాత ఇట్స్ నాట్ వర్కింగ్. సో దిస్ హ్యాపెండ్ గుడ్. 9 చివరి పెట్టినాం and this also happened good, but from here it's not what we expected. It should have been 7 here, but let's construct heap for this. From here let's continue the story. Okay, we have it already here. We construct the maps heap there. Let's go change. So let's make it 8. So 8 comma 2 we swapped. We made this 8, this 2, and then
5 2
2 and
3 2
so 8 to 5 comma 2.
3 gamma 2
Okay,
3 gamma 4
3 comma 2, right? That's it, nothing else. And then we swap Then this would be the actual now array. So 8, 5, comma 6, comma 3, comma 7, 0, comma 1, comma 2, comma 4. And at the end, I guess 9 would have been there somewhere now. So this would have been the array. So what did we get? So sample was this, max heap was this. After swapping we got 9 here and 2 here, and post that we have this, and it should start with 4, 4, 5, 6, 3, 7, 0, 1, 2, 8. This is also good. So I think this happened good. When there is right, then I think there is the issue.
6.
This was the error, right? So what we will do is we'll replace this with the last item, and we'll just remove this. This will become 8. This will become 4. This was what we were printing there. Okay. So 4 and 5. So 4 and 5. 4 and 3 is good. If 4 and 3 is good, I want to check 4 and 7. 4 and 7 is also good. I think then it is sorted only, right? No, 4 and 7, 7 bigger. Yeah, 4, comma 7. I think this step is not happening. 5 and 4 happen, so 4 and 7 is done. From this okay. 7, and this need to go again onto the top.
Yeah, 5 step.
We just stopped it there, I guess, right? Okay, that was the problem in our program. So we saw left. If left is okay, we are continuing till the left bottom. That's fine. If it is a small number, it's going on good. But if it is a bigger number, or when the right thing comes, according to the logic, left pass. So we changed the right node, we swapped, and we kept the J as this. So this is the J, and we're continuing with the J. I don't know why. I don't know why we stopped here. I think this should actually continue, and we need to make this as a heap again. So when we are inserting, how did it actually start? It was 5 here, it was 4 here, right? So 4 and 5 is swapped, and we checked this. This is good, so we checked this, and 7 came here, and 7 wants to come up again. Even in this case, if we are swapping the parent with a child, that means this can even go upper. This both needs to run till either they reach, they should have been a while loop like this here. Had this been an interview, I might have screwed up way badly. Okay, what we shall do is, let's take this as an assignment right now. Okay, let's kind of figure it out. I'll push this to a new branch. Okay, and all of us, let's try to figure out the solution, and whoever comes first is the winner.
Wow.
Okay, I think that would be a
Okay.
big challenge. Let's all debug this program. I think most of us know like what's going on right until now, right? So let's try to figure it out, like where we went wrong, and let's fix this code. So let me make the changes. Let me push it to Git. Git status. So I added readme. Okay, I posted a new branch. So to pull from remote, git checkout minus b minus help. Let's see, minus help. మైనస్ టీ అంట, నేను ఇక్కడ ఏంటో మైనస్ టీ పెట్టా. మైనస్ హెల్ప్ మైనస్ టీ అంటే ట్రాక్ అప్ స్ట్రీమ్ ఫర్ న్యూ బ్రాంచ్ అంట. మైనస్ టీ ఆరిజిన్ స్లాష్ శిరీష్ అండర్స్కోర్
HeapSort.
అండర్స్కోర్ HeapSort అని కొట్టండి. దిస్ ఈజ్ వాట్
Hmm.
you need to run to get a local branch of my branch.
Hmm.
కొట్టండి అందరు ఇప్పుడే. Do it with me. Let's all work on the same branch, okay? All of you switch to a new branch. మీ అందరికీ సిరీష్ HeapSort అన్న బ్రాంచ్ వస్తుంది. Let's figure it out.
Right. A branch.
సిరీష్ HeapSort అన్న బ్రాంచ్ వస్తుంది. If you press this,
Okay, okay.
నాకు ఆల్రెడీ ఎగ్జిస్ట్ అని వస్తుంది, మీకైతే వస్తుంది అనమాట. మైనస్ టీ ఆరిజిన్ స్లాష్ and someone write this to GitHub admin. I'm giving like 5-10 minutes, like take your time. I want someone to fix this. I'm taking a short break. You can talk. If you have any doubts, you can ask Jago. Ballu is on here. Is also a friend. First, you should do git fetch. Git fetch Jago.
వీటి మాస్టర్ బ్రాంచ్కి చేంజ్ అయిన తర్వాత మాస్టర్ బ్రాంచ్కి చేంజ్ అయ్యాను. ఆ? ఫస్ట్ టైప్ గిట్ ఫెచ్ అయింది. గేట్ చెక్అవుట్ మైనస్ టీ అదా? హలో నిశాంత్,
అన్నా
ఫస్ట్ గిట్ ఫెచ్ అని కొట్టు.
నాకు మీ వాయిస్ చాలా బ్రేక్ అవుతుంది.
గిట్ ఫెచ్ అని కొట్టు. ఫెచ్ FETCH.
గిట్ ఫెచ్. ఓకే.
ఫెచ్ అని కొట్టిన తర్వాత గిట్ చెక్అవుట్ మైనస్ టీ అని చూసావా? ఇప్పుడు చెప్పారు కదా మైనస్ టీ ఒరిజిన్.
గిట్ ఫెచ్.
ఫెచ్ కొట్టి ఎంటర్ కొట్టు.
ఓకే, గిట్ ఫెచ్ తర్వాత
గిట్ చెక్అవుట్ మైనస్ టీ.
హీప్ సార్ట్.
గిట్ చెక్అవుట్ మైనస్ టీ ఒరిజిన్ స్లాష్
అదే.
ఇప్పుడు చెప్పాడు కదా
ఆ,
టైప్ చేయి.
SHIREESH.
అండర్స్కోర్ HeapSort. CCTV new brand series HeapSort. ఈ సెటప్ టు ట్రాక్
అన్న అండర్ స్కోర్ షిఫ్ట్ అండర్ స్కోర్ కదా కొట్టాలి.
మైనస్ కొట్టి అండర్ స్కోర్ వస్తుంది. అదే ప్లస్ ఈక్వల్ టు పక్కన జీరో పక్కన.
అదే షిఫ్ట్ కొట్టి వస్తే స్పేస్ వస్తుంది.
గిట్ చెక్అవుట్ మైనస్ టీ
ఓకే, అది ఓకే అన్న.
స్లాష్
యా, అండర్ స్కోర్ స్పేస్ వస్తుంది షిఫ్ట్ మైనస్ కొడితే.
ఏమొస్తుంది?
షిఫ్ట్ మైనస్ కొడితే అండర్ స్కోర్ రావట్లేదు అన్న,
అవునా, రావాలి.
స్పేస్ వస్తుంది నాకు.
కింద అండర్ స్కోర్ కింద కనిపిస్తుంది చూడు.
ఆ?
హెచ్ హెచ్ పక్కన కింద కనిపిస్తుంది అండర్ స్కోర్ మధ్య.
అదే
అక్కడ
అండర్ స్కోర్ మైనస్.
లేదా?
అన్న అండర్ స్కోర్ మైనస్ తెలుసు అన్న, షిఫ్ట్ అది కొడితే నాకు స్పేస్ వస్తుంది మరి అంటున్నా.
అవునా, మళ్ళీ ట్రై చేయి. బ్యాక్ స్పేస్ తోటి మళ్ళీ ట్రై చేయి బ్యాక్ స్పేస్ తోటి.
అర్థం కాలే.
మళ్ళీ ట్రై చేయి మళ్ళీ.
యా, నేను అప్పటి నుండి చాలా టైం నుండి ట్రై చేస్తున్నాను, మైనసే వస్తుంది నాకు.
అండర్ స్కోర్ రావట్లేదట నిశాంత్ కి.
అండర్స్కోర్ రాకుండా అంటే
స్పేస్ వస్తుందంట. షిఫ్ట్ కొట్టి ఇది కొడుతుంటే స్పేస్ వస్తుందంట.
కీబోర్డ్ పెట్టుకోండి. కీబోర్డ్ ఈఎన్జీ పెట్టుకోండి. కింద ఈఎన్జీ రెండు కీబోర్డ్ పెట్టు.
ఏమి బోర్డు పెట్టుకోవాలి?
ఈఎన్జీ సైలెంట్ ఐఎన్జీ ఉంటుంది అక్కడ. కీబోర్డ్ పెట్టు. అదే స్క్రీన్ ఆన్ స్క్రీన్ కీబోర్డ్ పెట్టుకో.
ఆన్ స్క్రీన్ కీబోర్డ్ అని పెట్టుకో.
అన్న
ఆన్ స్క్రీన్ కీబోర్డ్ పెట్టుకో లేకపోతే.
చేస్తా.
అన్న ఈ అకౌంట్ గిట్ హబ్ గిట్ ల్యాబ్
వాయిస్ షుడ్
గిట్ హబ్ అకౌంట్ ఉంది కదా, గిట్ హబ్ అకౌంట్.
గిట్ హబ్
ఇయర్ ఫోన్స్ పెట్టుకోవచ్చు కదా.
so if it left is smaller, I think it's all good, but if it is bigger, we swap it. Post swapping it, I don't think we need to do this. J will not change because J is the parent. Left node is bigger than the parent. We are swapping the parent in the left. Yes, now the parent is bigger than that. And we want to check it against the okay. So default is this is good. We're good to go. also need to check. This is and if the parent node is commit, is not committed, then
Ballu అన్న, are you there?
Yeah,
ఆ
I'm
అన్న,
there.
ఓకే ఇట్లా వచ్చింది. Error your local changes to the following file will be overwritten by the coordinates. Please
Override.
commit. Hmm.
ఒక స్క్రీన్ చూపివా?
Okay.
marriage settings.
అన్న చూస్తున్నావా?
గిట్ సెక్షన్ కొడితే నీకు ఏమని వచ్చింది?
సెక్షన్ కొడితే నెక్స్ట్ ఆప్షన్.
అవును. ఏ బ్రాంచ్ లో ఇప్పుడు ఏ బ్రాంచ్ లో ఉన్నావు? గిట్ బ్రాంచ్ అని కొట్టు.
With status or with branch.
బ్రాంచ్
Master is origin.
గిట్ చెక్అవుట్ మాస్టర్ అని కొట్టు.
Error వస్తుంది.
అదే ఇక్కడ ఓవర్ రిటర్న్ వస్తుంది. గిట్ స్టాష్ కొట్టారు కదా. చెక్అవుట్ మాస్టర్ కొడుతుంటే ఫైల్ షుడ్ బి ఓవర్ రిటర్న్ బై
చెప్పండి.
గిట్ స్టేటస్. గిట్ స్టేటస్ కొట్టలేదు.
ఆ,
స్టేటస్
You have some changes, right? సో ఇప్పుడు నువ్వు దీన్ని ఏం చేయొచ్చు, ఐదర్ యూ కెన్ గిట్ చెక్అవుట్ మాస్టర్ కొట్టు.
అక్కడ మాస్టర్ బ్రాంచ్ లోనే ఉన్నాడు.
ఇది మాస్టర్, నువ్వు మాస్టర్లో ఆరిజిన్ స్లాష్ ఆరిజిన్
మాస్టర్ లో లేదనుకో origin.
ఓవర్ రిటర్న్ అని వస్తుంది.
ఇది అట్లా ఉండొద్దు కదా మరి. గిట్ యాడ్ డాట్ కొట్టు.
గిట్ యాడ్ డాట్ అదేనా?
Git
యాడ్
add.
డాట్ స్పేస్
అంతే, దీన్ని కమిట్ చేస్తే ఇంకా నీ బ్రాంచ్లోకే కదా.
Hmm.
Commit them so that
కమిట్
you can change into a new branch.
Git commit.
మైనస్ ఎం.
Is under permissions of changes.
Permissions కొట్టు. ఓకే.
కంట్రోల్ ఎక్స్, కంట్రోల్ ఎక్స్ ఎగ్జిట్ కింద ఉంది చూడు ఎగ్జిట్.
వై
వై,
వై ఎంటర్.
వై ఎంటర్ కొట్టు.
కంట్రోల్ ఎక్స్ మెల్లిగా మెల్లి మెయిన్గా కొడుతున్నావు ఆడ. ఫైల్ నేమ్ టు కమిట్ అంటావు, ఏంటో చేస్తున్నావు. ఎస్కేప్ కొట్టు.
అన్నా
ఎస్కేప్
ఓకే.
ఎస్కేప్ 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 ఎస్కేప్. కంట్రోల్ సి.
ఎస్కేప్
కంట్రోల్ సి.
కంట్రోల్
కంట్రోల్ ఎస్కేప్.
సి, సి
ఎస్కేప్
కంట్రోల్,
కనిపిస్తుంది, క్యాన్సిల్. కంట్రోల్ సి.
కంట్రోల్ సి క్యాన్సిల్ కనిపిస్తుంది కదా కింద.
కంట్రోల్ ఎక్స్.
ఇప్పుడు కంట్రోల్ ఎక్స్ కొట్టు.
వై కొట్టు.
వై, వై
కంట్రోల్ వై కాదు, కంట్రోల్ ఎక్స్
కంట్రోల్ వై
కొట్టాలి.
కాదు, జస్ట్ వై.
జస్ట్ వై అన్న నేను టైప్ చేసింది కదా.
కంట్రోల్ ఎక్స్ కొట్టు.
కంట్రోల్ ఎక్స్
కంట్రోల్
ఏం
సి.
రావట్లేదు.
కంట్రోల్ సి.
కంట్రోల్
ఓకే.
ఎక్స్.
కంట్రోల్ ఎక్స్.
ఎంటర్ కొట్టు.
సేవ్ మాట్లాడుకో నో కదా.
ఎంటర్.
ఎంటర్.
ఓకే షేర్ వస్తుంది.
కంట్రోల్ వై.
కంట్రోల్ వై.
ఓకే. షిఫ్ట్ వై.
నో కొట్టాలనుకుంటున్నా. సేవ్
ఇది వస్తుంది షిఫ్ట్ వై.
ఇది క్లోజ్ చేయాలి, నాకు తెలియదు ఇది అసలు క్లోజ్ చేయాలి. క్లోజ్ చేసేస్తాయి.
కంట్రోల్ సి కొట్టు చెప్తా. నో అని కొట్టు చూద్దాం అది కూడా.
అన్న
ఇంకో టెర్మినల్ ఓపెన్ చేయి. నువ్వు మైనస్ ఎమ్ కొట్టుకుంటా, ఇదంతా ఏంది అసలు?
స్టాండర్డ్ కంట్రోల్ ఆల్టీ.
మైనస్ ఎం పెట్టుంటే ఇదంతా అడుగుతుంది. అది మైనస్ ఎం పెట్టబోట్టమాట అంత అడిగింది.
ఏ- హలో
హలో హలో
అన్న టర్మినలే కదా ఇప్పటి వరకు ఓపెన్ చేసింది.
టర్మినల్ కనిపించట్లేదు నాకు.
ఇందాక వరకు ఉన్న కంట్రోలే కదా.
ఆ డైరెక్టరీలోకి వెళ్ళు. ఇది ఏప్రిల్ 2 days డైరెక్టరీ దగ్గరికి వెళ్ళు. సిడి 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 డెస్క్టాప్ ట్యాబ్ కొట్టు. మొత్తం కొట్టక్కర్లేదు, ట్యాబ్ కొడితే అది వచ్చేస్తుంది. ఎంటర్. మళ్ళీ ఇందులో ఏ ఫోల్డర్లో ఉంది? సిడి సిడి నిషు సంథింగ్ ఉంది కదా, నిషు పైథాన్. ఎన్ఐ కొట్టు, ట్యాబ్ కొట్టు. సిడి ఏప్రిల్ ట్యాబ్. ఓకే.
ఓకే.
ఎంటర్. స్టేటస్ కొట్టు.
స్టేటస్ ఇప్పుడే ఉంటాను గిట్ ఫెచ్.
గిట్ కమిట్, గిట్ కమిట్ మైనస్ ఎం.
అప్ టు డేట్ ఉంది.
బ్యాక్వర్డ్ బ్యాక్వర్డ్ బ్యాక్. గిట్ చెక్అవుట్ గిట్ బ్రాంచ్ అని కొట్టు. గిట్ చెక్అవుట్ మాస్టర్. ఎంటర్.
Please commit changes of stash.
గిట్ కమిట్, గిట్ కమిట్, గిట్ స్టేటస్ కొట్టు. ఓకే ఓకే. గిట్ కమిట్
Commit
మైనస్ ఎం
minus n
ఇన్వర్టెడ్ కామర్స్ స్టార్ట్ చేయి.
inverted comma.
సంథింగ్ ఏదో మెసేజ్ కొట్టు అందులో. కమిట్. మళ్ళీ క్లోజ్ ఇన్వర్టెడ్ కామర్స్. ఎంటర్ కొట్టు.
Okay.
ఇంకా గిట్ స్టేటస్ కొట్టు. స్టేటస్ స్పెల్లింగ్.
నథింగ్ టు కమిట్ వర్క్ currently అంట.
గిట్ చెక్అవుట్ మాస్టర్ కొట్టు.
Git checkout master nothing. Git pull to update అంట. Git pull కొట్టాలి.
ఇప్పుడు గిట్ ఫెచ్ కొట్టు.
Git normal H.
ఫెచ్ FETCH.
It is ఇంకా
అరే గిట్ ఫెచ్ అని కొడితే ఇలా రాలేదేంటి?
ఇక్కడ మరి ఫస్ట్ ఏదో వచ్చింది కదన్న.
ఒక్క నిమిషం.
Your branches behind 4 commits and can be fast forward. Use git pull to update your local branch.
ఒక్క నిమిషం.
Git pull అని కొట్టాలా?
గిట్ ఫెచ్ అని కొడితే
అంతే అన్ని బ్రాంచెస్ వచ్చినాయి. ఇప్పుడు ఇందాక కొట్టిన కమాండ్
మనోడికి రాలేదు అట్లా.
ఏమొచ్చింది?
గిట్ ఫెచ్ అని కొడితే నెక్స్ట్ లైన్ వచ్చేసింది.
ఏం లేదు, ఆల్రెడీ ఇంతకుముందు ఒకసారి చేసింటాడు కదా, అందుకే నేను రాలేదు.
ఓకే గిట్ చెక్అవుట్ -c.
Git checkout series అన్నారు కదా.
అది
అదేంటి?
టైప్ చేయలేకపోతే
Git
చెక్అవుట్
ch
-t
-t
శిరీష్ అండర్స్కోర్ HeapSort.
ఓకే అంతేనా అన్న?
అంతే అంతే.
కొటేషన్
ఎంటర్ కొట్టేసి
వచ్చింది.
ఓకే.
బ్రాంచ్ ట్రై మేనేజ్ చేయాలి.
మిస్సింగ్ బ్రాంచ్ ఏమో ఆరిజిన్ స్లాష్ సిరీస్ HeapSort. సిరీస్ HeapSort ముందు ఆరిజిన్ కొట్టి స్లాష్ కొట్టు. ORIGIN
సిస్టమ్ బ్రాంచ్ వచ్చేసింది మరి. హలో అన్న, వచ్చేసింది ఏంటో మరి. ఇది అంత ఎందుకు చేసామని అసలు
వీడు సపరేట్ గా బ్రాంచ్ క్రియేట్ చేశాడు. వీడు మనం వాడుకోవడానికి.
సో మనం మాస్టర్లోకి పుష్ చేయలేము కాబట్టి, ఎందుకంటే ఇట్ ఇస్ నాట్ ఏ వర్కింగ్ కోడ్, ఇట్స్ నాట్ ఏ ఫిక్స్డ్ వర్షన్ కాబట్టి మాస్టర్లో పుష్ చేయలేకపోయినాం. అందుకనే అదే బ్రాంచ్ మీద మిమ్మల్ని కూడా వర్క్ చేయమని అడిగింది అనమాట, నా బ్రాంచ్ మీదనే. సో దెన్ పోస్ట్ దిస్ అనుకున్నాం. 7 5 6 3 4 2 and this will be 2 3 4 0 7. obviously 8,9 ఇక్కడ ఉండాలి. 2563401 ఇక్కడ వరకు పర్ఫెక్ట్ వచ్చింది. నెక్స్ట్ ఇక్కడ ఫసక్ అయిపోయింది బేసికల్లీ.
కొంత టైం టైము 1:30
అది చేయండి.
10:30
2 5 2 3 2 ఈ కండిషన్లో ఇక్కడ దాకా వచ్చినాం, బట్ వీ డెంట్ చెక్ 6. నాట్ హీపిఫైయింగ్ ప్రాపర్లీ. ఐ డోంట్ థింక్ వాడి కింద రాసిన ఫంక్షన్ వెరీ స్మాల్ ఉంది, మనకి ఇంత పెద్ద ఫంక్షన్ రాసినాం హీపిఫైకి. వీఆర్ మిస్సింగ్ హీపిఫై. హౌ టు హీపిఫై పాయింట్ పైన ఇన్సర్ట్ చేస్తే కింద ఇన్సర్ట్ చేస్తే 2 ways ఉన్నాయి ఇన్సర్ట్ చేయడానికి హీప్లోకి. I think I need time to. When I'm not feeling satisfied, I think I can write few more lines and come to a solution. It can be there. రమేష్
అన్న
ఏమన్నా వచ్చిందా మరి నీకు?
అంటే ఫస్ట్ వైల్ లూప్ పైన ఫర్ లూప్ ఉంది కదా, పైన ఫస్ట్ ఫర్ లూప్ ఉంది కదా,
ఇది ఇన్సర్షన్.
ఆ ఫర్ లూప్ లో వైల్ లోనే మనం రెండు చెకింగ్ చేసుకుంటే సరిపోతుంది అనిపిస్తుంది. లెఫ్ట్ రైట్ ఇక్కడ వైల్ జే ఇస్ నాట్ ఈక్వల్ టు 0 అని ఉంది కదా, అందులో అండ్ అని పెట్టేసి శాంపుల్ ఆఫ్ జే గ్రేటర్ అని పెట్టాం కదా, అది జస్ట్ మనకు అరేని అరేంజ్ చేస్తుంది. అందులో ఇంకొక స్టెప్ తీసుకొని లెఫ్ట్ రైట్ కూడా చెక్ చేస్తే అన్నీ అయిపోతుంది అనిపిస్తుంది. మనం ఇదంతా రాయాల్సిన అవసరం లేదు అనిపిస్తుంది.
రాసి పంపించి మరి సేమ్ దీని ఇదే ప్రోగ్రామ్ మీద ఎడిట్ చేయి.
ట్రై చేస్తాను ఒకసారి మళ్ళీ అల్గోరిథం రాస్తాను.
బేసికల్ నేను ఫైనల్గా పేరెంట్ రీచ్ అవుతున్నా, బట్ పేరెంట్ రీచ్ అయిన తర్వాత ప్రతిసారి రైట్ కోడ్ చూడాలి, నేను చూడట్లేదు అది.
అవునన్నా లెఫ్ట్ అంతా మంచిగా అరేంజ్ అవుతుంది,
లెఫ్ట్స్ అవుతున్నాయి కానీ రైట్స్ అవ్వట్లేదు. అండ్
రైట్ అయ్యాక మళ్ళీ లెఫ్ట్ కూడా అవ్వాల్సి వస్తుంది ఒకసారి, ఆ కేసు మిస్ అవుతుంది.
ఎప్ ఎగ్జాక్ట్లీ. దీన్ని కొంచెం స్మూతర్ అండ్ మనం రికర్షన్ రాకుండా ఇటరేషన్ రాస్తున్నాం కాబట్టి కొంచెం కోడ్ కూడా పెరిగిపోతుంది. వాడేమో రికర్షన్ చేసేసినాడు కాబట్టి వాడికి ఈజీ అయిపోయింది, బట్ ఇటరేషనే చేయాలి. డోంట్ డూ రికర్షన్ కింద సొల్యూషన్ ఉంది, నాకు ఇటరేషనే కావాలి. ఓకే, ఇది హోంవర్క్లో ఇస్తాను ఇవాళకి. I think we crossed the limit. We crossed 1 o'clock. So let's stop it here. I want you guys to come up with a non-recursive solution. Don't call the function in itself. You can separate the logic out to a different function. That's okay. But don't call the function itself. Okay?
ఓకే
I want you to do it with iteration. I want you. Let's have a class in the morning or somewhere in the evening to just understand if anyone finds a solution, right? Let's have a class tomorrow.
ఓకే
Okay, just for this heapsort. Cool then. టేక్ ఆఫ్, హ్యావ్ ఫన్, గుడ్ నైట్. అదే మరి పాపం అందరూ వెళ్ళిపోదాం వెళ్ళిపోదాం అని ఉన్నారు ఒక్కొక్కళ్ళు. 1 second before we talk anything.